Your Copilot problem isn't actually a feature problem. It's a trust problem in the model behind it. Most teams still think safety lives in prompts, permissions, and a few filters at the edge. But here's the thing. Attackers don't need to beat your prompt. They just need to poison the context around it. And that's where things break. Basic filters can catch obvious junk, but they miss the payload hidden in an email, a SharePoint file, or a form field. This retrieved content sits there quietly until Copilot pulls it in and treats it like a direct instruction. We've already seen the warning signs with Echo Leak in Microsoft 365 Copilot and Share Leak in Copilot Studio, and the reality is that patches didn't end the pattern. Because Copilot can search, summarize, and act across your entire Microsoft 365 environment, one bad instruction path can spread fast. So this isn't about adding another dashboard to your stack. It's about putting Azure Logic Apps in the path to inspect, score, and block malicious payloads before Copilot ever runs. The real danger is the architecture, not the prompt. The old model assumes you can keep the system safe by writing better instructions around the model. You give it a strong system prompt, you add delimiters, and you tell users what not to do. That sounds sensible on paper, but in reality, the model doesn't enforce trust boundaries the way a security system would because it reads language in one shared channel where instructions and data compete for attention. That assumption is the flaw. If a model can't reliably tell the difference between a user asking for help and a document quietly telling it to ignore prior instructions, then the control point can't sit only at the prompt layer. You're trying to secure behavior at the edge while the actual risk sits in the flow of context moving into the model. This clicked for a lot of teams once retrieval-heavy Copilot workloads showed up. The moment Copilot starts pulling from Microsoft Graph, emails, files, and chat history, the attack surface changes completely. You're not just securing a conversation anymore, you're securing a live stream of mixed trust inputs. And one level deeper, Copilot increases reach. It doesn't just answer questions, it retrieves, it summarizes, and it follows references. In some setups, it can even trigger tools or workflows. So when untrusted content enters that chain, the model can carry that influence forward into sensitive actions. That's why indirect prompt injection matters so much right now. In production systems, the common attack isn't always a user typing "ignore your rules" into the chat box. The more dangerous version sits inside retrieved content, often weeks before anyone even notices it's there. A poisoned document, a crafted email, or a form entry might look harmless to humans, but it contains instruction language aimed directly at the model. Later, Copilot retrieves that content as relevant context, blends it with trusted material, and the model follows the wrong thing. The attack chain is simple, and that's what makes it dangerous. First, the attacker plants content in a place Copilot can later reach. Then retrieval brings that content into the session. Then the model treats the payload as an instruction instead of data. After that, it can start staging sensitive information, shaping responses, or pushing data toward an exfiltration path through links or tool use. So for leaders, this isn't just AI hygiene. It's runtime control tied directly to access governance. If Copilot has broad reach across the tenant, and the model consumes mixed trust context without hard separation, then your security model has to account for what enters the flow before execution. Once you see that, the fix changes too. You stop obsessing over perfect prompts, and you start placing enforcement where the context moves. Why basic defenses fail in production. Most teams make a fundamental mistake right at the start. They assume the security controls they've used for years in app development will work just as well for Copilot. They write a stronger system prompt, wrap user input in special characters, and publish some employee guidelines. Then they feel safe. Those steps aren't bad, and I wouldn't tell you to stop doing them, but they don't create a real security boundary. They are just trying to persuade the model to behave, and in security, persuasion is not the same as enforcement. That is where the gap lives. A system prompt tells the model what you'd prefer it to do, but it cannot stop a malicious file from competing for the model's attention once that file is pulled into the workspace. Using delimiters might help structure the text, but it doesn't give the model a way to check security clearances. Employee guidance is great for stopping honest mistakes, but it does absolutely nothing against a poisoned document or a hidden payload sitting in your retrieved data. The control exists as a suggestion, not as a hard rule that runs at execution. Regex has a similar problem. It is fast and cheap, so it's worth using as a quick first pass. If a user types "ignore all previous instructions," your system should catch that in a few milliseconds. You can also use it to flag obvious privacy bypass phrases or SQL-style characters in your tool arguments. That part works fine. But regex only recognizes patterns you have already defined, so it fails when the wording changes slightly or when the attack is based on meaning rather than specific words. This is why you need classifier layers. Azure AI Content Safety has prompt shields that can detect both direct and indirect injection attacks. In a Logic app, you can call an API to check the prompt before the model ever sees it, then change the path of the workflow if an attack is detected. This is a much stronger control than simple string matching because it looks for the intent behind the words across the prompt and the documents together. Even then, detection isn't enough on its own, because seeing a risk doesn't matter if you don't have a way to stop it. Security teams often underestimate this specific part of the process. A warning in a log file is not containment, and a pretty dashboard tile isn't containment either. Even a high-priority alert in your CM fails if the payload has already moved through Copilot and triggered an action in a downstream system. Reviewing what happened after the fact is helpful for an investigation, but it isn't good enough when an attack happens in seconds. You are dealing with a model that can act inside systems that your organization already trusts. There is also a problem with false negatives that most product marketing ignores. Indirect attacks cause a huge portion of missed detections in the real world because the dangerous instruction looks perfectly normal until the model combines it with the rest of the conversation. By the time a human reviews the output and realizes something is wrong, the bad input has already finished its job. The practical mistake here is very simple. Teams spend all their time watching what Copilot says, but they don't control what goes into it with the same level of discipline. They inspect the answer after it's generated while letting untrusted material flow in before the work starts. That order is completely backwards. Once you recognize that flaw, the entire goal of your security strategy changes. You stop asking how to write a safer prompt and start asking where you can intercept the data before the model executes. The Logic App firewall model. If interception is the goal, we need to look at what that control actually looks like in practice. You should use Azure Logic Apps as a policy layer that sits in front of the execution phase. It shouldn't be a passive tool that sends a report after the damage is done. You need to put it directly in the path where user input and retrieved data live so they can be inspected before the model gets to work. This shift is powerful because Logic Apps is built for orchestration. It can trigger on specific events, call out to other APIs, and make decisions based on complex conditions. You can route data, send alerts to Microsoft Sentinel, and enrich the process with outside information without building a custom security gateway from scratch. You aren't trying to replace Copilot here, you are just inserting a layer of control into the flow around it. The logic behind this model is simple on purpose. First you trigger the process, then you normalize the data. You inspect it, score the risk, make a decision, and finally route or log the result. That is the entire pattern. When a request or a piece of content enters the workflow, the Logic app pulls that payload in and standardizes it. Raw inputs are usually messy because different connectors handle data in different ways. An email looks different than a form entry, and file content or tool arguments all come with different metadata and fields. If you try to run an inspection before you normalize that data, your detection system is going to be incredibly noisy. Once the payload is flattened into a consistent format, the first inspection pass begins. This is where your custom regex still has a job to do. It isn't the final judge or a magic fix, but it works as a very fast filter at the edge of your system. You can quickly scan for known override language, encoding hints or suspicious patterns in tool parameters to give yourself an instant triage of the situation. Then you move to the second inspection pass, which goes much deeper into the content. This is where you call the Azure AI Content Safety Prompt Shields. The Logic app sends the user prompt and any retrieved documents to the API and then branches based on whether an attack was detected. This matters because prompt injections don't always look like obvious computer code. Sometimes the danger only becomes clear when the prompt and the document are evaluated as a single unit. There is one more layer that turns this from a simple filter into a real security control, and that is threat intelligence. If a piece of content references a known malicious domain or a suspicious URL that your team has seen before, that should change your decision. Logic apps can check the event against Defender threat intelligence or other third-party feeds to add a confidence score to the risk. This means a strange pattern from a trusted source might be allowed to pass, while that same pattern paired with a hostile reputation score gets blocked immediately. This turns your decision tree into something more than just a yes or no choice. You can allow the request if the risk score is low, or you can sanitize it by removing the unsafe fragments. You might choose to quarantine the data if the source needs a manual review. If the action involves sensitive data, you can even require a human to approve it before it moves forward. Of course, if the signal is strong enough, you simply block the request and fire off an alert. That range of options is what makes this model actually work for a business. Security teams often kill adoption because they deny every case that looks slightly uncertain, and when controls are too strict, people find ways to work around them. A scored workflow gives you the room to respond based on actual risk instead of panic. This is exactly why Logic Apps is a better fit than a collection of separate tools. It already connects to the rest of the Microsoft ecosystem and works perfectly with Sentinel playbooks. You can call for a content safety check, look up threat data, and push audit events all in one place. You don't need a long development cycle every time an attacker changes their phrasing or a new way to enter the system appears. The rule that makes this all work is very straightforward. You must treat every single piece of context as untrusted until it has been scored. That doesn't just mean the user prompt, it means the body of the email, the uploaded file, and the SharePoint form field. It includes the connector payload, the retrieved document chunks, and even the tool arguments. All of it has to be checked. The moment you assume one of those sources is safe by default, you have created a new gap for an attacker to use. Once your workflow enforces this rule consistently, you no longer have to rely on Copilot to separate good data from bad data on its own. The process becomes a controlled entry system. On paper, that sounds like a great theory, but what people really care about is what happens when a dangerous payload actually hits the workflow in the real world. what the workflow actually does at runtime. When this system goes live, it doesn't just scan text for bad words, it builds a full picture of the request before any decision is made. An event hits your ingress point, maybe a form submission, an email flow, or a document upload tied to a Copilot process, and Logic Apps immediately wraps that event with metadata. It tracks who sent the request, which app touched it, where the file originated, and what the system is about to do next. This extra context is vital because the same sentence can mean something completely different depending on where it comes from. Once that data is captured, the payload gets split into specific trust zones. You have to keep the separation clear. The user prompt goes in one bucket, retrieved documents go in another, and conversation history or tool parameters get their own space. If you mash all of these together too early, you lose the ability to tell where a risky instruction actually started, and your review process turns into total guesswork. Many teams skip this step because combining everything feels faster, but in reality, it just hides the path you need to follow. Next, the workflow moves into normalization. This is the boring part of the job, but it's also what makes your detection actually usable. You need to strip out markup that adds noise, decode URL encoding or base64 traces, and flatten nested fields so the inspection runs against a stable shape. If one connector sends rich text while another sends JSON fragments, you want them all reduced into fields your checks can read consistently. Without this, your logic spends more time fighting format drift than it does finding actual attacks. After the data is clean, the fast pattern pass runs first. This needs to be cheap, direct, and quick. You're looking for phrases that try to override system behavior, like variations of ignore all previous instructions or system override. You also look for extraction language where someone asks to reveal confidential material, dump secrets, or bypass privacy settings. In Logic Apps, teams usually handle this through expressions or compose steps that set flags rather than blocking the request immediately on every single hit. That flagging is important because a single phrase doesn't always mean someone is being abusive. A person working in a valid security workflow might literally need to ask about reviewing confidential content handling. To solve this, the workflow sends the richer payload to Azure AI Content Safety Prompt Shields for a deeper look. The API call includes both the user prompt and the retrieved documents because the relationship between them is usually where the real problem hides. The service returns a simple signal, and if an attack is detected, the workflow just changes the path before the model call ever happens. Then you need to add outside context. Threat intelligence lookups give the workflow another lens to see through. You can query Microsoft Defender Threat Intelligence or any tax UI source you trust to check for domains, URLs, or source indicators associated with abuse. You should pull in confidence scores where they're available because a source's reputation should influence the final score, not replace it entirely. A weak payload from a risky source should always rank higher than that same payload coming from a well-understood internal process. Finally, the system builds a composite score. It looks at pattern hit strength, the prompt shields result, source reputation, and how sensitive the requested action is. A low-risk request to summarize a public article doesn't carry the same weight as a request that could expose protected files. This combined score is what drives the branch. Clean events continue as planned, medium-risk cases get sanitized or routed to a safe fallback, and high-risk cases get blocked before Copilot ever runs. Everything gets written to an audit trail with the decision path preserved. These blocked events are what teach you where the pressure is building and which sources keep causing trouble. When you see which patterns are slipping into your business workflows, you finally have the data you need to tune the system for the next round. How to tune for low noise and real business use. Once the system is running, the nature of the work changes. Building the flow is actually the easy part. Tuning it so people trust it and don't try to find workarounds is what decides if this becomes a real security control or just another failed experiment. If the system creates too much friction, users will simply find a way to bypass it, which makes the entire project pointless. You should start narrow. Don't try to watch every single Copilot touchpoint on day one. Instead, pick the places where the risk is highest and the path is clear, like tool-enabled actions or high-value data sources. You might start with one SharePoint-backed process or a specific form workflow to get a signal you can actually read. Small scope gives you the room to learn without drowning in data. When you set up your initial checks, tune your rejects for recall rather than absolute certainty. The first pass is supposed to catch suspicious language early, not prove malicious intent beyond a reasonable doubt. If you force your patterns to be perfect, they become brittle and start missing the very things you care about. It is better to let the system over-flag a little bit at the start and then let later checks add context to reduce the noise. This is why scoring matters more than single hits. A phrase match on its own shouldn't always kill a request, but when you combine that match with a prompt shields flag and a risky source, the picture changes. Weak signals should stack on top of each other, and strong signals should accelerate the block. This is the fundamental difference between a rigid, annoying filter and a policy model that actually works for a business. You also need to set a ceiling for false positives. Try to keep it under 2% because once people feel the control is blocking their normal work, they will stop trusting the system. That's when the workarounds start. Users will copy text into unmanaged tools, teams will build shadow flows, and admins will start asking for blanket exclusions. The control will collapse from the inside, not because the detection failed, but because the friction became too much to handle. To prevent this, you have to watch the right metrics. Forget vanity dashboards and focus on the mean time to detect. You want to keep that under 15 minutes for anything that requires a manual review. You should also track your automated containment time and aim for under 5 minutes, where blocking can be done safely. If the workflow fires constantly but never actually influences a decision, it's just noise. Cost is another factor that needs constant tuning. Consumption-based logic apps are great for bursty workloads or small pilots because you only pay for what you execute. However, the standard plan makes more sense once your event volume is predictable and high enough that per-run costs start to hurt. Don't guess on this. Measure your actual trigger counts and payload sizes before you commit to a pricing model. Be careful with how you handle storage. You need enough run history for incident reviews and governance evidence, but you don't need a massive database full of sensitive content. Keep the specific fields that explain why a decision was made and drop the clutter that creates a retention risk. Storing too much data can turn your security tool into a privacy liability if you aren't careful. Finally, connect all of this tuning back to your broader governance. Map the workflow to NIST AI RMF functions like measure and manage, and tie it to your data sensitivity labels in Purview. Sometimes the best fix isn't a smarter detector, but simply removing unnecessary reach from the workflow before it ever becomes a problem. When you reach that point, you aren't just debating AI safety in the abstract anymore. You're running a real operating model with thresholds and trade-offs that a business can actually manage. What this changes for leaders and architects. Once you put this in place, Copilot stops acting like a blind trust system, and that is where the real shift happens. Before this change, the model just received a mess of mixed context, while your team hoped the right instructions would win out. Now that context gets screened, scored, and routed before the model ever gets a chance to touch it. The security outcome isn't just some abstract policy anymore, because now it functions as controlled execution. For architects, this moves where security actually lives in your design. It no longer sits only in tenant settings, permissions, or prompt templates, but instead it sits directly in the transaction path. Every request that matters gets an interception point, and every sensitive action follows a specific decision path. This means every new connector, agent, or plugin becomes something you evaluate as an input path rather than just another productivity feature. This is vital because architecture drift is usually why these programs fail. One team rolls out Copilot for a single use case, then another team connects a form, and eventually someone adds a workflow or gives an agent tool access. Each of these changes looks small on its own, but together they create a much larger attack path than anyone ever planned for. If you don't build interception into your operating model, the environment is going to expand much faster than your controls can keep up. For security leaders, this approach finally fixes a messy ownership problem that plagues most organizations. Right now, Copilot risk usually falls into the gaps between different teams. The SOC sees the alerts, the Microsoft 365 admins see the configuration, and the AI owner only cares about adoption. When you use a Logic Apps control path, all these groups can finally work from a single response model. They use the same event trail, the same scoring logic, and the same branch history, which reduces total confusion when a risky prompt or a poisoned document shows up in a live workflow. The business side of this is much more direct than people expect. Blocking a threat early is always cheaper than trying to clean it up later. Cleanup involves investigations, legal reviews, and user interruptions, and it usually ends with an ugly round of access reviews that should have happened before you ever deployed. Leaders don't need a long lecture on AI ethics to understand that, as they just need to see that runtime control costs less than letting unmanaged risk spread through the systems their staff use every day. For executives, this brings up an uncomfortable point about where risk lives. AI risk isn't sitting in a sandbox or a lab pilot anymore, but it now sits in Word, Outlook, SharePoint, and Teams. People already assume these places are safe enough to move fast, and that borrowed trust is exactly what raises the stakes for the company. A bad workflow in an experimental app is a contained problem, but a bad workflow inside your daily productivity stack is a completely different story. Your rollout path should stay small and very deliberate. Start with one use case, one trigger, and one scoring model. Pick a path where the data actually matters and the behavior is easy for you to observe. You need to prove that the workflow catches risky inputs and routes the clean ones while giving humans something useful when a review is needed. Once you prove that works, you can start to expand. Later on, you can add anomaly detection or output controls where they fit. You can even add deeper monitoring for tool misuse, but you must keep the first gate right where the untrusted context enters the system. If that first gate stays weak, every control you add later is just trying to compensate for a bad starting point. The shift here is actually very simple. Stop treating prompt injection like it's just a wording problem and start treating it like runtime control over untrusted context moving through Copilot. Take the time to map one Copilot workflow from end to end this week. Find the last safe interception point before execution and build one logic app that scores, blocks, and logs that specific path. If you want more on Copilot security without the fluff, subscribe and leave a review. You can also connect with me, Mirko Peters, on LinkedIn to tell me about the specific tenant scenario you are trying to secure.